So we discussed that asynchronous. What we discussed asynchronous subcounter. Okay, for passage of for passage or negate. Asynchronous up counter uh, for negate, no, for negate of clock, negate of clock. Negate of clock. So for the negate of clock, so means what we did. So we took three T flip flops. So three T flip flops like this. We took, and next. So this one is T naught, Q naught, T1 Q1, Q1, and T2 Q2. So this T inputs are connected to toggle state, no? Yeah, toggle state, and we given the negate of clock, and this Q is acting as a clock for the next flip flop, no? This Q is acting as a clock for the next flip flop that we discussed. Okay, so that is up counter. Okay, asynchronous 3-bit up counter. Okay, Q is acting as a clock, asynchronous up counter. Uh, so here, so that means this is acting as clock for the next flip flop. Okay, next flip flop. This is what we call, this is up counter. Okay, so if you want to design down counter, what you need to do? So here this is the Q naught bar, no? So this is Q naught bar and Q1 bar and Q2 bar. So you need to use this as clock, then that becomes a down count. Understood? Hmm. Up, so this is up counter means up counter, you understood, no? Down counter means how to design. Down counter means you have three flip flops. Okay, uh, three flip flops. So this one is T naught, Q naught, Q naught bar, T1, Q1, Q1 bar, T2, Q2, and Q2 bar. Okay. So here anyway this T1, T naught, T2 are connected to toggle state. Okay. This when Q naught bar is acting as a negate of clock, then it acts as which counter? Down counter. Okay. So that you can analyze. Okay. Suppose for passage of clock, for passage of clock, suppose if you want to design up counter, what you need to do? Up counter. So three flip flops are there. Three flip flops. Three flip flops, and this is passage of clock. T naught, Q naught, T1, Q1, T2, Q2. Okay. So Q naught bar, Q1 bar, Q1 bar, and Q2 bar. So this is acting as a clock for the next flip flop. If it is up counter, if it is a passage of clock, this should be act as a clock for the next flip flop. Understood? If it is a passage of clock, Q naught bar is acting as a clock for the next flip flop in order to design the up counter. Suppose down counter is there. So down counter means you need to use the same like Q naught as acting as a clock for the next flip flop for passage of clock. Okay, so here directly passage of clock is taken. Q naught is acting as a clock for next flip flop, and this is Q1 is acting Q1 is acting as a clock for next flip-flop. So anyway, T0, T1 and T2, these are connected to toggle state. Is it fine? Do you understood? So if for the negage of clock, Q0 is act as clock means it is up counter. Okay, negage of clock. And when for negage of clock, Q0 bar, Q1 bar, these are acting as a clock means this is down counter. Okay. For passage of clock, Q0 bar is acting as clock means. Am I audible? Hello. Acting as clock means then this is the up counter, and next Q0 is acting as a clock means this is the down counter. Is it fine? Do you understood? Okay. Yeah. So so do you want to design any counter or you will try? Okay. Which example you want? Down counter, huh? Passage or negage? Positive edge. Positive edge. Okay. Positive edge down counter. Okay. So positive edge down counter means so here I am drawing the three flip flops. Okay. So down counter, down counter, positive edge, positive edge. So here if you see three flip flops are there. So I am using T flip flop only. T naught, T1, T2. These all are connected to which mode? Toggle state. Yeah, toggle state means it is 1. Okay. I am giving passage of clock. If it is passage of clock, if I want to design down counter, then I need to use Q naught as a clock, no? This one. Q naught as a clock. Okay. So Q naught is acting as a clock for next flip flop. And this is Q1 is acting as a clock for next flip flop. Okay. So this I need to realize. Okay. So here I am writing clock and Q2. Q2 is nothing but MSB, no? Rightmost bit is MSB. This is MSB of the flip flop, and this is the LSB of the flip flop. Okay. So leftmost this Q naught is nothing but LSB of the flip flop. Okay. So Q2, Q1, and Q naught. Q naught is LSB of the flip flop. Okay. So if you are applying initial clock 0, all the states will be what 0 only, no? All the states will be 0 only. Okay. So clock 0. So you are applying clock 0. All the outputs of the flip flops will be 0 only. Okay. And you are applying first clock. Okay. Every time this will toggle, no? Every time first flip flop will toggle. Okay. So this is going from where to where? 0 to 1 means passage or negate? Passage. Passage means what? This will also toggle. This becomes it will toggle from 0 to 1. Again 0 to 1 passage or negate? Again this also toggle. So first clock pulse it will start from where? 1 1 1 1. Okay. And next second clock pulse will see. Second clock pulse. Again this will toggle. 1 to 0. Passage or negate? Negate. It will be previous. It will stay in its previous state. 1 1. No transition. So that means it will stay in previous state. Okay. 110, 110, and next case, third clock pulse, it will toggle from 0 to 1. So 0 to 1 means passage. Again this will toggle 1 to 0. 1 to 0 means negate, it will be in the previous state. At third clock pulse, it will be 101. Okay. At fourth clock pulse, we'll see. At fourth clock pulse, this will toggle from where to where? 1 to 0. 1 to 0 means negate, it will be in the previous state only. So no transition. This will be 1. Okay. 4, 1, 0, 0, 0. At fifth clock pulse, it will transition from 0 to 1. Okay. So 0 to 1 means again it will transition from 0 to 1. Again 0 to 1 means it will transition from 1 to 0. Okay. So at fifth clock pulse what happens? At fifth clock pulse, 1 second. Yeah. Fifth clock pulse what happens? 0, 1, 1. Okay. 0, 1, 1. Yeah. Fifth clock pulse, it is 0, 1, 1, 1. At sixth clock pulse, this will become 0, 1, 0. It will be in the same state only. No transition. It will be same state. Sixth clock pulse, 0, 1, 0. Okay. At seventh clock pulse, what happens? Seventh clock pulse, this will transition from 0 to 1, and this will transition from 1 to 0, and it will be previous state only. So seventh clock pulse, 0, 0, 1. Okay. Eighth clock pulse, it will transition from 1 to 0, and it will be previous state only. Why? Because negate of clock, no. So no transition, previous. So no transition, 0 only. So 0, 0, 0. It will come to the initial state, no. Okay. Is it down counter? No? Is it down counter or up counter? Is it down counter or up counter? I'm asking you. It's down counter, no. Down counter. Initial state is 0, 0, 0. After that, it is becoming what? 1, 1, 0, 1, 1, 1. Again 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0. So this is down counter. Yeah, yeah, down counter. So that means if you draw the state diagram, so it will start from where? 0, 7, 6, 5, 4, 3, 2, 1. Again it is coming to 0. Okay. Is it fine? Okay. And next we want to design counter with mod less than 2 power n. Okay. To design a counter with mod less than 2 power n. Okay. So less than 2 power n means if you want to design suppose mod 3 counter or mod 6 counter or mod 12 counter. Okay. Mod 13 counter. Okay. What is the process? We'll see. Okay. Is it fine? Okay. So first, so I am writing the steps. First step, forcing the counter to or set itself at a predetermined value by activating asynchronous input. By activating asynchronous input. Okay. Asynchronous inputs. We already discussed asynchronous inputs. What are the asynchronous inputs? Do you remember? Tell me. Clock is a synchronous input. Clock is nothing but output will be synchronous with the clock. So we discussed a separate waveform with respect to asynchronous inputs. I explained the separate waveforms with respect to D flip-flop. Preset and clear. I explained on preset and clear. Uh, Preset and clear. Hmm. That is okay, but during the flip-flops, we discussed about a separate concept called asynchronous inputs with respect to D flip-flops, preset and clear. I explained one waveform now, separate waveform I explained. In the during the flip-flops, I explained before conversions, I explained one preset and clear on the with one some waveforms I explained. Okay. So that means here, what are these asynchronous inputs means irrespective of irrespective of this input and clock. Preset means what? It will force the output to one. Okay. Clear means what? Irrespective of input and clock, it will force the output to zero. Okay. Next, uh, the logic for clear or set, that is active low, okay, pin, uh, active low pin depends upon the flip flop which have high or low outputs, which have higher high or low outputs corresponding to the modulus of the counter. Okay, corresponding to modulus of counter. Okay, modulus of counter. Okay. Uh, so the these flip flops output of these flip flops go to NAND or OR gate, and output of NAND or OR gate is connected to clear terminal of all flip flops. Okay, is connected to clear terminal of all flip flops. Okay, all flip flops. If it is active low, okay, if it is active low clear means so flip flop outputs are NAND or that is connected to the clear signal. Okay, for active high, what you need to use? For active high, clear or set pin, use which gate means and or nor nor gates. Is it fine? Okay. So when we design these circuits, you can understand very well. So I want to design mod 6 counter, mod 6 counter. Okay. So mod 6 counter. So mod 6 counter means what is the count operation? 0, 1, 3, 4, 5. Again it should start from 0, 1. Okay. What it should skip? Tell me. 6 and 7 it should skip. 6 and 7 it should skip. Okay. Step 1. Step 1. So you need to find out the number of flip flops. Yeah. So for finding out number of flip flops, you are using this formula, no? N is less than or equal to 2 power n. You are using this formula, no? You need to find out. So that is mod. Mod equal to what? 6 is less than or equal to 2 power n. Okay. Suppose if you are keeping n equal to 2, 6 is less than or equal to 2 square. 6 is less than or equal to 4. Is this condition is satisfying or not? No. No. Yes. 6 is, suppose any if you take 2 cube, 6 is less than or equal to 8. What about this condition? Now it is correct. Okay. So now how many flip flops are required? 3 flip flops are required now. And next, so how many flip flops means 3 flip flops here is required. And type of flip flop means I am using JK flip flop, that too in operated in which mode means toggle mode. Okay, toggle mode. Okay. And next you need to design mod 8 mod 8 counter, mod 8 counter, which is nearest to full modulus counter, which is nearest to full modulus counter, full modulus of counter. Okay, modulus counter. So what is nearest? That is mod 8 only, no? For mod 6 counter, what is the nearest? Mod 8 only, no? Mod 8 only. Okay. Step 3. Step 3. Count when counter output reaches, counter output reaches, counter output reaches 110. Okay. This activates the reset pin. Activates reset pin. Reset pin. Activate the reset pin using combinational circuit. We need to use one combinational circuit. By using that combinational circuit, we will activate the reset pin. Is it fine? Okay. So I will design this. See here. First, I will develop a. mm, I will develop a logic. Okay. I will develop a logic. So let us take QC, QB, and QA. Okay. QC, QB, and QA. Okay. And this is reset logic. Reset logic. Okay. So it will start from where? 0, 0, 0, 0, 0, 1. Okay. 1 second. 0, 1, 0, 0, 1, 1, 1, 1, 1. Okay. So here, uh, so till 5 it is 1 only, no? Till 5 it is 1, and here it becomes 0. Here it becomes 0. Okay. So what is my reset logic? Tell me. Reset logic. reset logic, summation of m of, tell me the minterms, 0 to 5, no? 5, yeah, 5, okay. So you need to draw the 3 variable map. What are the inputs? 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 2, 3, 5, 6, 7, okay. So 0, 1, 2, 3, 4, 5, no? 4, 5, okay. Remaining 0 only. So this is one quad, no? And this is one quad, okay. So this is QC bar. What is this? QB bar, na? Okay. So my equation is QC bar plus QB bar. This you can write as QC QB whole bar. QC QB whole bar. Okay. So just draw the 3 flip flops. JA, KA, QA. One second. JA, KA, QA. JB, KB, QB, JC, KC, QC. Okay. So here I am using negate of clock. If it is up counter, which if you are using negate of clock, if you are using up counter, which one you are using as a clock? QA, no? For negate of clock. QA, no? Up counter, up counter. So that is QA I need to use as clock. Okay. And next two more inputs are there. This is preset. Okay. This is preset. And one more, this is active low signal. This is clear. For each and every flip flop, preset, preset, and this one is clear. Clear. Okay. Here also preset, and next is clear. Okay. So here, so QB, QC whole bar, no? So this is QB and QC connected to NAND gate, and this is given to clear signals. Clear signals. Okay. So we'll test the cases. Okay. Yeah. Tell me one case from 0 to 5. 1, 0, 0. Okay. You told this state. So output is 1, 0, 0. Okay. When both are 0, 0, what is the output? 1, no? So 1 means clear will be active or deactive? Deactive. Deactive means normally it will count. Understood? Normally it will count. Suppose if we take 6, okay. So this is 1, 1 and 0. Okay. 1, 1, 0 means 1, 0 means this is output equal to what? 0. So that means this will clear that means clear is activated, 0 is applied to all the clear signals, it will come to the initial state 0 0 0. Is it fine? Can you design mod 6 with active high clear? You need to design mod 6 with active high clear. Can you design? Okay, yeah. Okay, that is your task. This is your task. Need to design. If you are feeling any difficulty, I will tell you. Don't worry. Okay, okay, yeah. So next, same thing. You need to design decade counter. Decade counter means what? Decade counter means it should count from 0 to 9. Again, it should repeats. Okay. So that means 10th count. So when 10th count is getting, so it is given to what? So it is given to reset. Okay, a reset or clear. Okay, reset or clear, and it will make all the flip flops to 0. Okay, all the flip flops to 0. So how to design? So here I am using so or otherwise you can make the logic also. So how you can make the logic? Let us take Q naught, um, Q3, Q2, Q1, and Q naught. Okay. Uh, so this is so here this is output y. Okay. 0 0 0 0 0 0 0 1. Okay. Uh, till here up to 1001 1001 the output will be 1 only, no? Okay, from 1010 to 1111 1111 output becomes 0. Okay, output becomes 0. Okay, one second, I'll close this. There is some problem. Oh, okay. Yeah, you see here. So okay, so here if you see, so you need to draw the K map. Need to draw the K map. Okay. Uh, so so what are the inputs? Q3, Q2, Q1, Q naught, Q naught, 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Yeah. So from 0 to 9 all are 1, no? 0 to 9 8 8 9 8 8 9 8 9. Okay. Mm, or otherwise here you can uh, 3 5 12 12 11 12. Here you are getting Q3 So otherwise you can design like this. Suppose 4D flip flops are there, 4 JK flip flop, 4 JK flip flop. Let us take J0, K0, Q0, J1, K1, Q1, J2, K2, Q2, J3, K3, and Q3. Okay. These both are connected to which state? Toggle state. No? Toggle state means this is given to 1. This is given to 1. Okay. 1. It is given to 1, logic 1. And I am using negate of clock. Negate of clock means Q0 is acting as a clock for next flip flop. Q0 is acting for the clock for next flip flop. Here what I am using means so 1010. So 1010 means Q1 and Q3. Okay, Q1 and Q3. I am connecting to Q1 and Q3. I am connecting with the NAND gate and NAND gate. This I am giving to clear signal. This I am giving to which signal? Clear signal. Okay, clear signal. So when you are getting that is 1 0 1 0, the output of NAND gate becomes what? 0, no? It will activate the clear. So it will clear from where? 0 0 0 0. Did you understood how I am doing? Okay, this is nothing but decade counter. So it will count from the name itself, decade counter. It will count from where to where? 0 to 9. Okay. Yeah. So with this, we completed the asynchronous counters. Any doubts or queries in this asynchronous counters? Hmm. Okay, sure, sure. Okay. Any doubts is there? You can ask me. So I will clear your doubts. Tomorrow we'll start the synchronous counters. Okay, synchronous counters.